Standard 8 Maths Chapter 12 Exponents and Power. Hello everyone. In this video we will start with what are exponents and powers, and we will see its different aspects, like how these are used for comparing larger numbers or smaller number, what are the different types of exponents, and so on. So now to start with, suppose if we have to write a number or we have to represent a number, like we have to say distance between two cities like A and B. It is 100 kilometers. So we can write this 100 easily. Okay. Now suppose the distance increases. It has become 1000. Still we can 1000 kilometers. Still we can write it very conveniently or very easily. Now what happens when this distance or not only distance but some other parameters. Suppose we have to show a distance of, say this is 10 crores kilometers. Suppose if we have to represent this distance, it becomes very inconvenient to write this much value. Okay, so now in order to simplify these, in order to write it in a very convenient way, we are using the exponential form of number. Now what is exponential form? See, this 100 can be written as 10 into 10, or simply we can write it as 10 to the power 2. Okay, this 1000 can be written as 10 into 10 into 10, that is 10 to the power 3. Suppose this it is 10,000, so it can be written as, how many zeros are there? 1 2 3 4, so it can be written as 10 to the power 4. Now this number, this will be, how many zeros are there? 1 2 3 4 5 6 7 8. It will be 10 to the power 8. Now tell which is easier to write, this exponential form or this number. Obviously this exponential form is very easier to write. So these exponents, now these are the case where we are writing larger numbers. There are cases like if you talk about the diameter of a cell which is very small, or a size of electron or weight of electron that is in very very minute quantity. So these exponents can be, by the help of these exponents we can write those values very conveniently. So from above discussion, what are exponents? What are exponents? Exponents are the quantity that represent the power to which a given number is to be raised. Exponents, these are the quantity that represents the power to which a given number is raised. What does it mean? Suppose if I am writing 2 to the power 3, this 3 represent the exponent, or sometimes we call as power, 2 to the power 3. So this number, this particular number will show that how many times this 2 has to be multiplied. Suppose this is to the power 3, that means this 2 has to be multiplied 3 times. Okay, fine. Now if I am writing 5 to the power 4, this 4 or this exponent or this power 4 will represent how many times this 5 has to be multiplied. So it will be written as 5 into 5 into 5 into 5. Okay, so these are the exponents or powers. So this particular value, that 5, this is called base, and this 4 is called exponent. Exponent or power. Clear? So there are two types of exponents. Like first we have positive exponents. Positive exponents means where power is a positive number, like 3 to the power 3, 4 to the power 5, 5 to the power 6. These 3, 5, 6, these are the exponents, and these are the positive number. So these positive exponents, they are used to represent larger number. These are used to represent larger number. Like we are representing 10 to the power 5. So it will be, okay. So positive exponents which have got the power as positive number, which are used to represent larger number. Now, second is negative exponents or negative powers. So when we are writing 10 to the power minus 2, 10 to the power minus 3. So these are the negative powers or negative exponent. These are used to represent smaller number. These are used to represent smaller number. Means now we will discuss these things in a bit detail. Now look at this pattern. We are writing 10 to the power 3. That means 1000. 10 to the power 2. That means 100. 10 to the power 1, that means 10. 10 to the power 0, that is 1. Now every time we are decreasing the power. Here it was 3, here it is 2, here it is 1. Now the value is decreasing by 1/10 of the previous value. Now this 100 is 1/10 of this 1000. Now this 10 is 1/10 of this 100. The power is decreasing every time by 1/10 of 1/10 or whatever be the base. Now this is 1, 10 to the power 0 is 1, or any value whose power is 0, its value is considered as 1. Now if we are further reducing the power, that means we are reducing its power by 1/10. 1/10 of 1 will be 1 upon 10. Now, if it is minus 2, it will be further, if we are reducing by 1/10, it will be 100. If we are writing 10 to the power 3, it will be 1 upon 1000. Okay. So every time when we reduce power by 1, we are reducing the present value by 1/10 of the previous one. So I hope you understand the pattern. Okay. So this is 1 by 10, 1 by 100. It can be written as 10 to the power 2. Okay. Now what does it mean? It means 10 to the power minus 2 is nothing but 1 upon 10 to the power 2. It is just the reciprocal of the positive power. Clear? Now we will take few more examples. Like we have 5 to the power minus 3. It means 1 upon 5, 5 to the power 3. If we are writing 2 to the power minus 4, it means 1 upon 2 to the power 4. So what does it mean? This is the multiplicative inverse. Now what is multiplicative inverse? Multiplicative inverse. Multiplicative inverse of a number is that number which when multiplied to the original number gives a value 1. Suppose, like leave these exponents, I am writing about the normal numbers. So there is a number a. Now what is the multiplicative inverse of a? It is that number which when multiplied to a will give the result 1. Now a 1. Now what is to be multiplied to a in order to get this 1? It is to be multiplied by 1 upon a or the reciprocal, right? So this reciprocal of a number is a multiplicative number of this multiplicative inverse of this number. Now if I am asking for multiplicative inverse of 3, it will be 1 upon 3. Multiplicative inverse of 10, it will be 1 upon 10. Now clear what is a multiplicative inverse? So in terms of power, if we talk, suppose there is a general number a to the power m. What is the multiplicative inverse of this? It will be 1 upon a to the power m, and this 1 upon a to the power m can be written as a to the power minus m. Like in previous case, I have told that it is 10 to the power minus 2. It was 1 upon 100, and it can be written as 1 upon 10 to the power 2. So a to the power m is the multiplicative inverse of a to the power minus m. I hope you are clear with this concept. Now if I ask what is the multiplicative inverse of 8 to the power minus 2, it will be 8 to the power 2. If I ask what is the multiplicative inverse of 9 to the power 3, it will be 9 to the power minus 3. So this is the concept of multiplicative inverse. Now, there are few examples on page 194. Find the multiplicative inverse of 2 to the power minus 4. What is the multiplicative inverse of 2 to the power minus 4? It will be 2 to the power plus 4. Multiplicative inverse of 10 to the power minus 5. 10 to the power minus 5, it will be 10 to the power plus 5. Multiplicative inverse of 7 to the power minus 2, it will be 7 to the power plus 2, and so on. Clear? Now we have to study the laws of exponents, right? Laws of exponents. Law of addition. First is law of addition, or you can simply suppose there are two exponential number, like we have a to the power m and we are having a to the power n, and these are multiplied. Okay, their bases are same, so what it will be, it become a to the power m plus n. If the bases are same, then their power will get added up. Now, if I am multiplying 2 to the power 5 into 2 to the power 6, what the result will become? It will become 2 to the power 5 plus 6. It becomes 2 to the power 11. Clear? One more example. 7 to the power 3 into 7 to the power 4. It will become 7 into the power 3 plus 4. It is 7 to the power 7. It is a law of addition. If there are two exponential number, that is a to the power m and a to the power n, their bases are same, their power will get added up. Now, second law is, if there are two numbers, if they are in division. Earlier it was case of multiplication, now it is a case of division. There are a to the power m and a to the power divided by a to the power n. Their power will get subtracted. It was in case of multiplication, it was addition. In case of division, it is subtraction. Now example, it is 8 to the power 5 divided by 8 to the power 2. It will become 8 to the power 5 minus 2, that is 8 to the power 3. Their bases has to be same. So this thing has to be kept in mind. Now this is clear. Now there is one more. If there is a to the power n raised to the power n, okay, it will become a to the power m into n. Example is 5 to the power 3, its whole raised to the power 4. It will become 5 to the power 3 into 4. 5 to the power 12. Clear? It is 6 to the power 2 whole raised to the power 5. It will become 6 to the power 2 into 5, that is 6 to the power 10. Likewise. Clear? Now further, if there is a raised to the power m and b raised to the power m. Now up till now we have seen their bases were same. Now their bases are different. Powers is same. What happens? It is applicable in the case of multiplication only. It will be a into b raised to the power m. Fine. Now this is 4 to the power 2 and 2 to the power 2. It will become 4 into 2 to the power 2. Their powers has to be same. It will be 4 into 2, it will be 8, 8 to the power 2. Suppose there is 7 to the power 4 and this is 5 raised to the power 4. It will be 7 into 5 to the power 4, that is 35 to the power 4. Clear? Now, if it is a upon b, a to the power m and b to the power m, it will be a upon b to the power m. Take one example like this is 3 to the power 2 and 4 to the power 2. It will become 3 upon 4 to the power 2. Clear? Now finally one thing. This is if any number has the power 0. It is value is always 1. If we write 2 raised to the power 0, it is 1. 3 raised to the power 0, it is 1. 1000 raised to the power 0, it will be 1. So these were the basic laws of exponents. Okay, we will deal with some examples and exercise 12.1 in our next video. Thank you.